Saxon Algebra 1, Lesson 82. Greetings, my student. That was a weird way of saying students. I said students. Evaluating functions. Oh, I spelled that wrong. Evaluating functions, and then we have a second topic, but this is our first one. Way back. It was in lesson 28 that we talked about functions for the first time. 28, and here we are in 82. Whoa, that's trippy. We just flipped the digits. But that was a long time ago, and I wonder how much you remember of lesson 28. This is what we see for lesson 82. And I'll write it down and then I'll explain what it means in case you don't remember. Using 2 lines because I ran out of space. Okay, if the f of x equals x squared plus x minus 10, find the f of 5. What that means is, here is what we call a function. All right? It's really just an expression that is named, and what we're asked to do is plug in 5. It's another way of saying this is let x equal 5. Okay, and we plug 5 into this, and then we get an answer for it. The way we write that, though, is to say the f of 5 equals, and then here's the unsimplified version, 5 squared plus 5 minus 10. Okay, I used buckets, and I put in a 5 anywhere there was an x. Oh, this is fun. This is super fun. Now we can say the f of 5 equals 25, and we can take those parentheses off, plus 5 minus 10. 30 minus 10 is 20, and that's the answer. So we say, if f of x equals blah, 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 find the f of 5. F of 5 equals 20. All right. Here's a slight wrinkle. And I think this is probably close to what we were doing in lesson 28, if that serves. This time we have a function that's named h. This is the h of x. Remember, this is one of the handy things about functions is that you can name them so that if you're talking about a bunch of equations at once, you can tell which one is which. And we're supposed to find the h, ready? This is weird, of a squared. Whoa! We're not substituting in a number like we did here. We're substituting in a different letter. But that's okay. It will work like this. The h of a squared equals, again with the buckets, right? Instead of x, x is where we put the bucket. So now we put a squared in plus a squared plus 1. That's not an x. Does that make sense? We still created the buckets where the x's were, and this time we plugged a squared into every bucket. All right, so now we just simplify to the a squared. Remember, this is our power rule for exponents that says if you're raising one power to a different power, whoops, an x, not an a, you multiply them, right? So this would be a to the 4th plus a squared plus 1, and that's the final answer. We can't simplify it any more than that. So yeah, it looks weird, but really, how hard is that? All we need is our little power rule over here, and all the rest of it was easy. It was cute. It was fun. Okay, I'm going to flip for the next problem so I don't run out of space. Example 82.3. This time, we're trying to find, okay, this is the f of x, x squared plus 1, and we're supposed to find the f of, ready, x plus 2. All right, that means for every bucket that has an x, we're going to pour in an x plus 2. Well, there's only one x bucket, but it's a doozy. We have to put x plus 2 in that bucket. So that means, ladies and gentlemen, that we have to square the binomial. There's no way around it. Kids have to go to Saturday morning dance class. Let's do it. X squared plus 2x. Now this way, another 2x plus 4. So this multiplied, I'm just going to write it up here. The f of x plus 2 equals, I forgot to write the square, x squared plus 4x plus 4. That goes up here. X squared plus 4x plus 4 plus 1. So as our final step, we can combine those. The f of x plus 2 equals x squared plus 4x plus 5. So the quote-unquote hardest part of this, the most annoying part of this, is multiplying the binomial, which came up right here. Okay? All right. Wow, look at that sun flare down on the corner of my page. Man, life is different when we have sunshine. Okay, part B. Domain and range. Oh. The dog that we had before Gracie was named Ranger, and I was just thinking about him when I was writing range, and I changed it into him. So this is memories of my pup. This is not the way his paws really looked, but pretend those are dog footprints. Okay. Domain, we have said, is a word that stands for our inputs. It's what we start with when we calculate, and we often associate it with x. Range has more to do with our answers or output, and when we're talking about graphing, it's more associated with y. Okay? You'll see how this is relevant in just a minute. Okay. This lesson is kind of confusing and obscure. Don't think about it too hard. Yes, Micah, I do mean you. Don't overstress yourself on trying to make this make sense. Just kind of float along with it. If the f of x equals 2x, we're supposed to find the domain and range. Okay, so what we're supposed to do is we're supposed to look at this and see, are there any limitations? Never mind, I don't want to say that. Are there any limitations on the numbers that we can put into this function? Is there any limitations we need to put on that x in order to keep this in the real numbers, which is basically what our goal is. We want to keep it real. See what I did there? Keep it real. We want real numbers. Yeah, that'll make more sense in another problem. Well, there's really no limitations that we can put on this. So we can say that the domain of x, the domain of f, this function, right? The name of the function is f. The domain of f equals the reals. We can really plug anything into this. It should work in the function. And the range of f, we'll get real numbers out, won't we? This is the answer. It's so generic that it's hard to understand what we're doing here. I want to skip to one that makes a little, well, we'll just go in order, but that doesn't really make a ton of sense to me. Don't worry if it bothers you too. Example 82.5. For f of x, our function is just f of x equals 3. That's weird, right? So what's our domain? Well, we're not really putting anything into this, but our domain could be anything, right? There's no limits because we don't really even use an x in there. The range, and I should say of f to make this most precise, I added it up there. No matter what we put into this, we're going to get out of 3, isn't it? Aren't we? So the range of this function is just 3. No matter what we put into it here, we're always going to get a 3 out. That's just the way it is. Weird, but this is almost easier to understand than this one, wasn't it? Okay, let's do another one that involves a picture. And these are where my brain goes, okay, finally you've given me something that makes sense. Here comes a graph. The graph starts here, and it goes out to and then and it looks like that. Now, we're not used to seeing things graphed like that, but John is telling us this is a function named f. These are values of x and y, we can think of them, and we want to know the domain and the range. So the domain of this f is going to be the range of the x values. Remember, this is the x-axis, this is the y-axis. I told you way back here that domain is associated with x and range is associated with y. We're going to use that information now. So to find the domain of f, we look at the x values. And we say that the domain of f is x is an element of the real numbers, because it includes all the little fraction bits, between, let's see, this is -2 and this is +3, right? It's an x, the values for x are elements of the real numbers such that -2 is less than x and is less than or equal to 3. What did I just say? I said x is an element of the real numbers because it's not integers, we're including all the little bits and bobs. And it's between -2 and 3 on the x-axis, right? Domain is associated with x, so we're looking at the x-axis. And it doesn't include -2, so I didn't put the equal sign there. But then the values go all the way up to 3 and including 3. So that's how I got that. For the range, we flip our brains, and now we're looking at the y-axis. We're looking at the variations in the numbers there. The highest y value is right here at 1, 2, 3, 4. And the lowest y value is down here at 0. So now you have to stop thinking about this x-axis that we looked at before, and now we're looking at the picture in terms of its up and down qualities. So the highest one is 4, the lowest one is 0. So we say the range of this function is that y is an element of the real numbers, because again, it's all the bits and bobs, it's not just dots on integers, such that 0 is less than or equal to y is less than or equal to 4. We don't have any open circles affecting this because this dot is higher. That's why we don't pay any attention to that. We look at the highest point and the lowest point of this picture. Okay? So the hardest part is shifting your brain so that you're not looking at the x's anymore, you're looking at the y's and comparing the high point and the low point. And then when we looked at the x's, right, we looked at the farthest to the left and the farthest to the right. And that is how we get our answers for this problem. This notation is weird. Just copy it until you think it makes sense. All right. Here's a couple more that I think are a little bit more logical, easier to understand what we're getting at. Find the domain of the function f of x equals square root of 5 minus x. Okay, remember when I said to keep it real? That means we can't have imaginary numbers in our output. So we have to set up our domain to make sure that this doesn't become a problem, because we want x or 5 minus x. That always has to be greater than or equal to 0. Do you see what I'm saying? If we let this number get too big, then we're going to have a negative number in our pig house, and then we're going to have an imaginary number, and we're trying to keep it real. That's our job. So we cannot let this x number get too big, because we have to make sure that this stays. It's okay if it's 0, but it can't be any smaller, or else we're imaginary, and that's not cool. So we can do the algebra on this. Let's just add x to both sides. 5 is greater than or equal to x. I'm just going to pick that up and flip it over so that x is where I like it. X is less than or equal to 5. And now we'll write it in this fancy language. We'll say the domain of f, that's the name of our function, is that x is an element of the real numbers, because we can have weird little decimally fractions in there as long as they're not too small. It's an element of the reals such that x is less than or equal to 5. That's our answer. This problem is easier to understand because we can more readily grasp what the problem would be. A negative number here would not let us to keep it real. That's a problem. And the last, somehow I got off on my numbers. Oh, I have 2 6s. This is actually 7. The last problem of this lesson is another one that's fairly easy to grasp. Find the domain of the function g of x equals 1 over x. Uh-oh, uh-oh, uh-oh. I see the flashing lights. I see the dust. I see the kingdom imploding in on itself, and it's not a pretty picture. Okay, that's the kingdom. It had all those lines on it, right? Like so. Something like that, and all the lights flash all the way around, right? It was cool. This cannot allow that to happen, or else the world will implode. So this is another one where it's like, okay, we get it. We can't have 0. Negative numbers are fine. Positive numbers are fine. Fractions and decimals of all sorts are perfectly fine. But the domain of g, x can be any element of the real numbers except x cannot be equal to 0. And that is our final answer. I think it's easier when John uses these kind of like extreme trouble situations where we know, okay, that would be a problem with a certain kind of number. And let me just show you in the homework. We did problems like all of these in our examples. So you can look to any of these if you get stuck. If the graph of function f, okay, so this is where we look at the picture, right? When we're looking at the x values, we look at the extreme left and the extreme right. When we're trying to find, that's for the domain, right? Because domain is associated with x. So we look at the high point and the low point on the x-axis. Then we find the range, and we have to switch our brain to looking at this. The highest point would be that one. The lowest point would be that one. And then we set it up accordingly. And then here's the last one that we were just working on, find the domain of this function. Okay, we have to keep it real, so that means this number, this 3 minus x, whatever's living in that pig house, that can be 0, but it can't be less than 0. So 3 minus x has to be greater than or equal to 0. Oh, I'm helping you with your... All right, that's lesson 82. This one kind of makes your brain feel crooked. Don't feel bad if it does. You're not going crazy. It's just a lot of weird ideas being thrown at you. All right, if you ever have questions, you guys, email me your, take a picture if you can, or just send me the lesson and the number of the problem, and I will work it out and send you a picture back so that you can see what you're getting into. All right, sorry about weird lesson 82. Good luck. I'll talk to you soon.